5-7 factor special products. On this video, I'm going to show you two examples of trinomials that actually have special patterns that actually can be factored quicker than using the factoring by grouping. So let's take a look at the first trinomial that I have here in red. It's x squared plus 8x plus 16. So when we had a trinomial with a plane x squared, we found that we could immediately put our parentheses because we would look at and say, what are the factors of 16 that give me a sum of 8? And I have my first term here, we would go x and x. And then we have what are the factors of 16 that give me a sum of x? So I can make my little table, and I'm just going to abbreviate here, f factors of 16 and sum of 8. And I can go down my factor list, 1 and 16 and 17, and I'm using positive numbers because both are plus plus here. 2 and 8 gives me a sum of 10, and here's the one I'm looking for, 4 and 4 for a sum of 8. So now since I have 4 and 4, I will go plus 4 and plus 4. Take a look at the answer of x plus 4 times x plus 4. There are couple of patterns I want you to notice. The first thing to notice is that notice what's inside the parentheses is identical. I have x plus 4 equals x plus 4. This trinomial, x squared plus 8x plus 16, is called a perfect square trinomial. The reason it is called a perfect square trinomial is it follows a set pattern. If you look here, I have x squared. Well, x squared is a perfect square. The square root of x squared is x. If I then have the square root of 16, the square root of 16 is 4. And notice I have that square root here. Next, when you do this, I could actually then rewrite this as saying that this equals x plus 4 squared. So in this perfect square trinomial pattern, I have an x squared here. I have a perfect square here at the end. So what is the pattern with the middle term? Let's take a look at if I take x plus 4 times x plus 4, and let me show you what that pattern is. I have x plus 4 times x plus 4. All right, and I will use the distributing. X times x, x squared. X times 4 plus 4x. 4 times x, 4x. And 4 times 4 is 16. Now, the middle term is 8x. Where does it come from? It comes from the 4x plus 4x. And what I want you to notice here is notice in the middle here the two terms are identical. So I actually have two of these 4x terms here, which also if you notice when I FOILed that, I got a 4x here, 4x here. So the pattern is this when you look at the trinomial. The first term is a perfect square. So we would say a squared. The middle term, if I take this number 8, I can say that is the same as 2 of the square root of my last term. So my last term is also a perfect square. That is b squared, because it could be a different number. And the square root, 4 times 4 is 16. So what do I say in the middle? I have 2 of a times b. Well, what is a? A is x. B is 4. So 2 times 4x, 8x. So again, it follows the pattern, perfect square, perfect square. If I do the square root of each of these, the square root of x squared is x, the square root of 16 is 4, 4x doubled is 8x. So it follows that pattern. Now, if you're not able to see that pattern right away, it's okay to do what we did in the beginning here. But what I'm telling you is when you factor these trinomials, check the outside terms. If they're both perfect squares, you can put their square roots here and here, and then check to see, do I have a double? If I multiply these out, do I have a double to get the middle term? So let's look at the one in blue. Do I have a perfect square here? 16x squared. Yes, 16 is a perfect square. X squared is a perfect square. Look at the outside over here. 9. 9 is a perfect square. Y squared is a perfect square. Now I have a 24 in the middle. All right, if I follow the pattern, since I recognize these to be perfect squares, all right, I would be writing this out as, if you want to factor by grouping, okay, then I need to know that in the parentheses in the end, I'm going to have this. I'm going to have, what's the square root of 16x? It's 4x. And I have to have one of those in each set of the parentheses. What's the square root of 9y squared? 3y and 3y. What sign goes in the middle? I have positive, so I have to go plus and plus. The question is, if I was to distribute this and remultiply it back, will I get 24xy in the middle? Well, I know 4x times 4x gives me the 16. 3 times the 3 gives me the 9y squared. 4 times, if I take 4x times 3y, I get 12y squared. 4x times 3y is 12xy. If I do 3y times 4x, I also get 12xy. So now I have two of those. 12xy doubled is 24xy. So this is also a perfect square trinomial. I have a perfect square on the first term, a perfect square on the third term. The middle term, if you do the square root of the first term, 4x, square root of the first term is 4x, square root of the third term, 3y, multiply those two together, 12xy, double that, I get 24. That means I have a perfect square trinomial, and I can factor that by saying, what is the square root of the first term? 4x. What is the square root of the third term? 3y. Both of the signs in the middle are pluses, so I have to have a plus here and a plus here, which can then be written as 4x plus 3y squared. All right, so sorry that was so sloppy, but let me type in here what I'd like you to do. Don't turn this in when you get done. There's more to do in the next video. It goes on page 310, and I want you to do numbers 1, 4, 6, and 7. That's it. 310, 1, 4, 6, and 7. You'll keep this when you get done because there's a couple more videos to watch before you're going to turn it in. All right, thanks, and let me know what I can help you with.